Hello, dear students. Let's start the new topic, taste and uses of the sulfuric acid. Now, this topic from chapter 8D, sulfuric acid, of class 10th in subject chemistry. So let's start the topic. First start the topic, test for dilute sulfuric acid and concentrated sulfuric acid. Dilute and concentrated sulfuric acid. Now, in this column the dilute sulfuric acid and in this column the concentrated sulfuric acid. So the dilute sulfuric acid is tested by using the barium chloride. So first added the barium chloride into the dilute sulfuric acid, and a white precipitate of the barium sulfate is formed, and the appearance of the white precipitate of barium sulfate indicates that the barium chloride added into a dilute solution of the sulfuric acid. So if any dilute acid gives the white precipitate of barium sulfate with barium chloride, then it's proved that the given acid is the dilute sulfuric acid. Conc sulfuric acid do not give the barium sulfate with barium chloride, and that barium sulfate is insoluble with dilute hydrochloric acid and nitric acid. Now the test for the concentrated sulfuric acids. Addition of copper. Adding some amount of the copper to the conc sulfuric acid and heated to the mixture of copper and conc sulfuric acids. After heating, we can observe a burnt smell of sulfur that evolved during that reaction. So the copper react with conc sulfuric acid, not the dilute sulfuric acid, and produce copper sulfate H2O and the sulfur dioxide. This sulfur dioxide is a colorless gas with a smell of burnt sulfur, and that copper sulfate also can be detected by passing this copper sulfate sulfur dioxide gases through the orange color of the potassium dichromate K2Cr2O7, and the orange color of the potassium dichromate finally changes into the green color. It's proved that the sulfur dioxide passes through the orange color of the potassium dichromate. So the production of the SO2 can also be detected by using the solution of potassium dichromate. Now next test, lead nitrate test. The lead nitrate is added to dilute sulfuric acid. A white precipitate of lead sulfate is formed, and this precipitate is insoluble in dilute hydrochloric acid and nitric acid. So lead sulfate react with dilute sulfuric acid, not the conc sulfuric acid, and to produce a white precipitate of lead sulfate, and that white precipitate of lead sulfate is insoluble in the dilute nitric acid and dilute hydrochloric acid. So it indicates that the given solution is the dilute sulfuric acid. Now the conc sulfuric acid test with the addition of the common salt sodium chloride. When common salt is added to the Kong sulfuric acid, hydrogen chloride gas is produced, and this hydrogen chloride gas is a colorless and having the pungent smell, acetic gas. The dense white fumes are seen if a rod dipped in the ammonia solution is brought near to it. So first the ammonia, rod which is dipped in the ammonia solution and brought near to the hydrogen chloride gas, then it's formed the ammonium chloride NH4Cl. It is a white fumes. That ammonium chlorides prove that the given gas is the released gas is the hydrogen chloride gas, and hydrogen chloride gas is only always evolved during the reaction between sodium chloride and Kong sulfuric acid. Now next topic, uses of sulfuric acid. First, uses. In the manufacture of sulfuric acid is used in the manufacture of fertilizer such as ammonium sulfate NH4 twice SO4 and super phosphate of lime, calcium phosphate plus CaSO4 is called the super phosphate of lime, calcium phosphate plus CaSO4. Next use is of the hydrochloric acid, sulfuric acid is in the chemical industries. It is used in the manufacture of hydrochloric acid in the industries, in the manufacture of nitric acid, phosphoric acid, metal sulfates, ether, pigments, plastics, film, cellophane, dye, drug, glue, disinfectant, perfumes, paper. So there are many uses of the sulfuric acid in the chemical industries. It is used in hydrochloric acid, nitric acid again, phosphoric acid, metal sulfates, ether, pigments, plastic, film, cellophane, dye, drug, glue, disinfectant, perfumes and paper, etc., etc. Now sulfuric acid is also used for the manufacture of explosives such as nitroglycerin and trinitrotoluene. TNT is called the trinitrotoluene and nitroglycerin. The nitroglycerin and trinitrotoluene is manufactured by the using of sulfuric acid. Next, used in the petroleum industries. In the petroleum industry is mainly used to remove sulfur and tarry compound from petrol, kerosene and lubricants. So unwanted compounds or sulfur related compounds can be mainly removed by using sulfuric acid in the petroleum industry. Next uses of the sulfuric acid is in the metallurgy, that is extraction of the metal from the ores, different ores. So in the metallurgy it is used for the extraction of copper metal, and purification of gold, pickling of metals, that is removing metal impurities before coating with zinc, tin, enamel, etc. So removing of the metallic impurities before the galvanization and tanning formation. So in the metallurgy the sulfuric acid can be used. Now next uses of the sulfuric acid is in storage battery. It is used as electrolytic medium in the accumulator, especially for the uses of automobiles, battery, etc. Now the next use of the sulfuric acid is in the laboratory. It is used as a reagent and as a drying and dehydrating agent. So in the laboratory it is used as a reagent and drying and dehydrating agent. Bromine, iodine, carbon monoxide, hydrogen are prepared in the laboratory by using the sulfuric acid. So sulfuric acid is used for the preparation of the bromine in the laboratory, iodine, carbon monoxide and hydrogen. Now the next use of the why the sulfuric acid is used for the preparation of bromine, iodine, carbon monoxide and hydrogen because it is hygroscopic in nature and it readily absorbs water vapor from the atmosphere and it therefore used as a good drying agent in desiccator in laboratory. So due to their hygroscopic nature, it is used as a good drying agent in the laboratory. Now next topic, the differences between drying agent and dehydrating agent. Here is the differences between drying and dehydrating agents. Now the drying agent first. The drying agent removes only the superficial water that's sticking to surface of a given substance. But the dehydrating agents remove the atom of hydrogen and oxygen in the form of water molecules from the composition of the substance. So the drying agent bring about a only physical change, but dehydrating agent bring about a chemical change. In the drying agent, no change in the chemical composition of a substance takes place when drying agent is used, but dehydrating agent, whenever you use, it bring about a change in the chemical composition of a substance. So H2SO4 is used as a dehydrating agent, not a drying agent. So this is all about the differences between drying agent and dehydrating agent. Okay, thank you. Have a nice day.